Alright, good morning everyone. Okay, so I hope all of you are already here. I see the list, we got about 29. Ada orang tak mute ke? Izzati? Alright. Okay, so here got about 29 students. So almost all is already here. So I will start our live demo for today. Okay, so as I told you masa dalam map text in the Teams, if you please make sure you have your lab manual with you so that you can understand better lah the lab. Okay, so I will show you each of the apparatus. I will explain to you the flow of the system, what is important for you. And the most important part is I really hope that you can understand lah macam mana kita dapat result tu sebab I give you the sample result, right? So my greatest fear is when I do this demo, you're not able to understand macam mana kita dapat result tu, then macam mana kita nak explain the result, so on and so forth. Okay, so this is the not so good part about doing live demo, tapi it's okay. I will try my best to explain. Yang penting for me personally, even if you don't come back for the lab, yang penting you understand apa tu reactors, okay, what's the basic configuration, the system, the parts, the important parts, and so on and so forth. Okay, so it will take only about 1.5 hours. So I will explain all 4 experiments for you. Okay, so don't forget. When I give you the schedule, you will see that eksperimen 1, 2 dan 3 you have A or B. Okay, so make sure you check betul-betul eksperimen 1A ke, eksperimen 1B ke, 2A ke, 2B, 3A, 3B, and then eksperimen 4 only one experiment. So tapi dia konsep dia masih sama. For example, eksperimen 1 still batch reactor. Okay, eksperimen 2 CSTR, eksperimen 3 plug flow reactor, eksperimen 4 reactor test rig. Okay, so hopefully if someday you come back, maybe kalau end of semester you ada come back my set ke, or probably next semester you turn up in my set, or for those who are taking design project, student process yang taking design project 1 next semester, I will still teach you design project 1, so maybe I can actually bring you in to show you the laboratory. Okay, so nanti saya pergi keluar. It's a little bit noisy because lab reaction actually is an open air, bukan open air lah, ada bumbung, tapi it's no aircon laboratory. It's quite noisy sebab dia open juga. So if you cannot really hear me, please tell me so that I can sound louder. Okay, I'm using iPad sebenarnya, so it will keep moving lah. So if you feel like macam betul-betul live demo lah when I bring you around. Okay, so I will start first with explaining experiment 1, batch reactor. Right, so masa saya jalan kepada, or maybe I show you first how the lab looks like. Hold on Yeah, let me show you first how the laboratory looks like. Okay. Okay, so if you can see clearly, this is lab 8. Sebenarnya sepatutnya you are supposed to run the experiment in lab 8. So this lab 8 ni we call it sepatutnya lah the common name we call it as unit operation laboratory, meaning all the pure chemical engineering courses, contohnya macam reaction, separation, thermodynamic tak, reaction and separations, all the apparatus are here. Okay, so I think I show you in general first. Okay, yang ni this is actually distillation. So when you learn separation, this is actually the distillation unit. So dia campur lah, dia ada separation dengan reaction punya apparatus is all here. So kalau kamu tengok dia memang open air, memang panas lah, tak ada aircon. So actually you are very lucky, you don't have to come back. Kalau tak memang student kalau buat lab reaction ni memang dia akan rasa panas sangat sebab tak ada aircon and it's a bit hot. But you can see the one that I want to highlight is that our apparatus are all the pilot scale. Okay, you can see it's big, right? So normally kalau you go to not many institute in Malaysia, I could probably attest that not many institution in Malaysia, chemical engineering, that offers pilot scale punya apparatus. So in the camera set is actually one of the very few in Malaysia yang mana equipment kita kalau kamu nampak is really all pilot scale equipment. Okay, so this is in general how lab 8 looks like. So if one day you really want to experience nak masuk betul-betul macam pilot plant, pilot scale punya apparatus, you can just contact me, I can bring you personally. Okay, so this is how the laboratory looks like. Okay, so safety issue, safety aspect, you know, right? So you can see if you go to any chemical laboratory or chemical plant, you will see there are special safety features that we take lah. For example, we have this yellow line. So you know this is to surround the equipment to show that if you enter into the space, it's considered as a higher risk. Okay, so you have to be very careful. You have to employ special security features lah. For example, you have to wear helmet, goggles, so on and so forth. Saya pun tak pakai. By right, I also did not follow, but I'm not running the experiment, so not too bad. However, you know lah, you are supposed to follow all this. Okay, so I go first to the very first reactor. Okay, so sebelum ni kamu selalu tengok sebelum ni kamu selalu tengok gambar kan. So let me now show you the real apparatus. So this is the real batch reactor. So kalau kamu check in the laboratory manual, this is actually how many liter? Let me check. Saya pun dah lupa. I think 10 liter. 10, right? I can't remember. I think this is 10 liter, but I might be wrong. I think it's 10 liter. Correct. This is a 10 liter vessel. Okay, sorry. This is a 10 liter vessel. Okay. So kalau batch reactor, let me first explain what are the system that comes with it. Okay, so of course yang paling basic mestilah dia punya vessel kan. So this is the batch reactor. Okay, so remember I told you the main difference between batch reactor and the rest of the reactor. Batch reactor is a closed system. Okay, apa maksud dia closed system? Okay, kalau kamu perasan, nothing goes in. I will only input my reactant inside here. Okay, so contohnya dalam kita punya lab, by right, we will run saponification. Okay, saponification tu actually a reaction between sodium hydroxide and ethyl acetate. So basically kamu buat sabun tau, sodium hydroxide, ethyl acetate, you will get sodium acetate, which is the soap, and you get ethanol. Okay, so kamu akan masuk sodium hydroxide, ethyl acetate inside this vessel. Okay. So kalau you read the lab manual, by right, for experiment 1B, okay, experiment 1A tak guna batch reactor ni. Experiment 1A guna in the chemical, in the lab is, 1A tu hanya buat eksperimen tu dalam beaker sahaja, or I would say experiment 1A ni lab scale. Experiment 1B betul-betul kita guna reactor. Okay, so for those yang buat experiment 1B, you realize you study the effect of temperature. Okay, so apa yang kamu buat untuk each experiment, you are supposed to prepare 3 liter sodium hydroxide, 3 liter ethyl acetate. Okay, so you will put in your ethyl acetate, you will put in your sodium hydroxide, equal molar, equal volume. Okay, so kalau kamu ingat, you're supposed to prepare 0.1 molar sodium hydroxide, 0.1 molar ethyl acetate. Okay, 3 liter, you will pour inside this vessel. So this is your inlet lah, kita panggil the inlet to the vessel. Okay, so you imagine, I already placed in the chemical, but right, sebenarnya untuk setiap reactor ni saya dah place in the chemical so that you can really see how it flows. Okay, so I put in the reactor, right? So by right 6 liter, right? Okay, dah so, alamak, kita jatuh. Okay, hold on. This is really demo. This is really live demo. Okay, so you place in, you close. So this is the main characteristics of batch reactor. It is closed system. So memang dah tutup, you dah tak kacau system during the reaction. Nothing goes in, nothing goes out. So to show the proof, what about the outlet kan? Kalau ada inlet, dia nak keluar kat mana kan lepas reaction. So after reaction takes place, okay, let's say reaction takes place for 10 minutes. So kamu biarkan 10 minit, okay. Then the outlet, kamu nak keluarkan sample is actually at the bottom. So you can see this is the bottom valve. Okay, so bawah ni ada valve. So the valve is actually V1. You see it's labeled carefully. So if you want, right now it's closed. So when you want to open, you will just open je lah. So when you open, then the reactant will flow out. Okay, so I hope you still remember in engineering, the rule of thumb when you want to open is always ikut clockwise. Ikut putaran jam is to open. To close is always counterclockwise. So engineering ni dia tak boleh buat. Okay, certain equipment buka clockwise, certain equipment anti-clockwise. Cannot. It's very standard engineering equipment. Kalau valve open is always clockwise. So let's say you join intern, your supervisor asks you to open WAF, you just remember dia punya fundamental dia, kalau nak buka clockwise. So for example, you see, this is I want to open clockwise. I want to close counterclockwise. So you can see reactant flows from top, then masuk dalam ni kan. If you realize inside is your the reactant. So saya nak letak reactant sebenarnya. Okay. But one thing you must remember, sebab this is a teaching reactor, that's why the reactor is made of glass, transparent. Okay, tapi in the industry, walaupun ada, but it's rarely lah kita guna glass vessel. Usually we will use stainless steel, so on and so forth. So kalau stainless steel, you tak nampak lah transparent macam ni kan. So sebab kalau you use glass reactors, dia ada limit kepada temperature. So you cannot go above probably 150 pun dah tak boleh kot Celsius. So that's why kalau reaction high temperature dia dah guna stainless steel. Even stainless steel pun dia ada grade-grade dia depending on temperature, depending on the pressure that you want to use. Okay, so just that for teaching reactor, kalau dia tak guna glass, nanti you cannot see what's inside. That's why they use a glass reactor. Okay, so this is a basic on reactor. Okay, next thing, kalau you realize, I taught you about heating jacket, cooling jacket, right? Okay, so kalau kamu nampak, probably not so clear. Actually, this reactor ada dua layer. Dalam satu layer, luar satu lagi layer sebenarnya. Because, I told you before, certain reactor they need higher temperature, ataupun they need to be heated or they need to be cooled. So kalau heated, the outer layer is a heating jacket. If you need to cool down, it becomes cooling jacket. So what is the function? Is definitely to heat up or cool down your vessel. Okay, so kalau we need to heat up, we sure need a heating fluid. Kalau cooling, we need cooling fluid. So depends. So kalau your reaction is below 100, normally we use water je. Okay, so in our case here, actually we use water. Okay, kalau kamu nak tahu macam mana, ada, kalau you perasan this one, F1 ni, this one, okay, you see at the top, this is actually to flow in your heating water. So kamu nampak dia akan masuk. So mungkin kamu ingat, ni macam flow in dalam reactor. Tak, dia akan flow in kan the outer vessel. So that the outer vessel tu will be filled up with water to heat up your reactor. So kamu just imagine I got two layer of vessel. The inside is reactor, the outer one is where you have the heating fluid or the cooling fluid. Okay, so that's one thing. Okay, next thing is, you know that batch reactor, dia punya concentration is always uniform. Meaning, concentration at the top, bottom, middle or anywhere in the vessel, dia punya concentration will be uniform, right? As well as temperature. So how do we do this? So we do this by using stirrer. So let me switch on the stirrer. So if you can see, there's a stirring motion. Okay, so sebab air dia tak jernih sangat, kamu tak nampak. Tapi if you can feel, dia ada macam stirring motion, right? So I've switched on the stirrer. Okay, so perhaps we might think stirrer ni macam quite simple. However, there are many studies done on the configuration, the shape, the design, even the height of the stirrer. Sebab the design of the stirrer, the height of the stirrer, the configuration. Contohnya dalam reactor ni, because it's a small reactor, kita just guna satu stirrer. However, kalau dalam industri, this one 10 liter kan, kalau your reactor is like 30 liter, 50 liter, you might even have double or triple stirrer. Ni stirrer dia akan macam lapis. So you have 3 stirrer at different height, because kalau satu stirrer, kalau reactor tu panjang dan besar, satu stirrer will not be enough. So they have until 2 or 3 triple stirrer to ensure the reactor concentration is maintained uniformly. Okay, then next. Macam mana kita nak determine result dia? So kalau you see experiment 1B, you will have, I already provide you the sample of result. The results are in the form of conductivity. Kalau kamu tengok sample result tu, saya bagi kamu conductivity. Mungkin kamu terfikir, macam mana kita nak tahu apa tu conductivity? Why do we measure conductivity? Okay, if you remember, Okay, kita kan kalau nak buat reaction, kita kena monitor concentration of reactant kan. So dalam case ni, kita ada dua reactant, sodium hydroxide, ethyl acetate. Okay, so kita tak monitor both concentration. Kita hanya monitor sodium hydroxide, or we can say sodium hydroxide is our A. Okay, the main reactant A. Okay, so macam ni kita nak tentukan the concentration of sodium hydroxide during the reaction. Sebab ingat kan saya kata kita prepare sodium hydroxide for the experiment is 0.1 molar. Okay. Tetapi kamu jangan lupa, when you prepare 0.1 molar sodium hydroxide and also 0.1 molar ethyl acetate. Both pun equal volume kan, 3 liter you will put inside the reactor. So dalam reactor ni, concentration asal tu dah menjadi separuh. Kalau kamu ingat M1, V1, M2, V2. V1 tu yang kamu prepare 3 liter. Masuk dalam reactor dah tambah lagi 3 liter ethyl acetate, dia dah menjadi 6 liter. So the concentration become half of its original value. Maksudnya kamu prepare 0.1 molar tapi dalam reactor ni actually dia adalah 0.05 molar. That is the initial concentration before you start the reaction. Okay, right. Then kita dah belajar in reaction, concentration will decrease with time kan, sebab sodium hydroxide will be consumed during the reaction. Maksudnya dia akan bertindak balas untuk menghasilkan produk, mestilah kepekatan sodium hydroxide will decrease. So macam mana kita monitor atau kita record this concentration of sodium hydroxide? We use conductivity. Okay, so macam mana kita guna? Okay, now if you realize, now I teach you how to read engineering punya identification. Okay, if you see here, it's written as Q1401. So if you read, Q is actually to stand for the conductivity, I indicator lah. So actually patutnya they don't use C, they use Q. So it's conductivity indicator 401. Okay, so it means that is actually a conductivity probe. So kalau kamu tengok hitam tu, dia ada satu probe. Kalau kamu tengok probe tu masuk sampai ke dalam. Okay, I don't know you realize. Okay, there's the black probe. Yang black tu, the probe, that's the conductivity probe. So conductivity probe ini, okay, ataupun kamu boleh bagi macam sensor lah. We call it probe. Engineering wise we call it probe. So this conductivity probe will then record ataupun will sense the conductivity, will measure the conductivity and will give you the reading of the conductivity. So conductivity ni reflects kepada kepekatan sodium hydroxide. So kalau kamu tengok in the laboratory manual, there is a calibration table tau. Dan calibration table tu dia dah bagi nilai mana kalau conductivity dia by right, if you prepare 0.05 molar of sodium hydroxide, conductivity dia adalah 10. Itu memang standard. Okay? Sodium hydroxide, conductivity 0.05 molar yang dalam reaktor ni adalah 10 nilai conductivity dia. Okay? So lepas tu, what happen is, of course lah bacaan pertama kamu bermula daripada conductivity 10. Then this 10 will reduce, right? Sebab more sodium hydroxide will be consumed. Okay. So you will see that from this conductivity probe, you will get the reading of the conductivity and then kamu record conductivity tu. Okay. Then you will know what's the concentration. Maksudnya daripada conductivity calibration table, okay, yang diberi, you have to plot a graph. Okay, graph tu kita panggil calibration curve. Daripada calibration curve tu, you will get an equation. Kamu guna equation tu untuk relate balik bacaan conductivity kamu kepada concentration. Okay, maksudnya katakan you do the calibration curve, you get the equation. Okay, kamu tahu kan equation daripada curve mestilah y equals to mx plus c kan? Okay, so daripada calibration curve, kamu akan dapat persamaan tu. Contohnya y equals to 10x plus 4. So 10 tu adalah dia punya gradient, 4 is the y-intercept. Okay, y tu adalah conductivity, X adalah your concentration. So when from the calibration curve tu kamu ada persamaan. Okay, lepas tu kamu tengok reading kamu. Conductivity tu kamu jadi Y kamu. So kamu dapatlah nilai X. Nilai X tu adalah your concentration. Or simple word if you cannot imagine, katakan. Ataupun senang katalah. Okay, katakan daripada calibration curve kamu tahu 10 tu maksudnya conductivity 10 means concentration sodium hydroxide 0.05. Okay, so katakan kamu baca balik conductivity dalam result tu turun kepada 7. Okay, so kamu tengoklah berapa dia punya concentration. Kamu guna calibration curve. Okay, now how do we know the reaction has ended ataupun dah habis ataupun all your reactant has been consumed? Okay, we can know that when your conductivity goes below 4. Sebab kalau conductivity goes below 4 means there's no more sodium hydroxide. Sebab conductivity 4 tu adalah conductivity for water ataupun basically neutral. Okay, so kalau conductivity turun bawah 4 maksudnya dah tak adalah sodium hydroxide dalam kamu punya reactor, or means to say all sodium hydroxide already reacted. Okay, so kalau kamu tak sure sangat, please check the calibration table. Okay, kamu akan tengok pada bacaan conductivity 4, concentration sodium hydroxide tu adalah kosong. So normally student akan monitor conductivity sampai bawah 4, dia tahulah means reaction tu dah habis sebenarnya. Okay, alright. So another thing that I forget to say, kan experiment 1B you will compare different temperature kan. Okay, so we will heat up our reactor. So in this reactor configuration, kita guna water bath. Okay, tapi biasa dalam industri taklah guna water bath. But this is a 10 liter reactor. They just use this water bath. So this water bath will heat up your water and then will flow into your reactor. Okay, so you can see this is the stirrer motor. Okay, this is stirrer motor. So you see kalau kamu nampak dia kata M1 kan, this is M1. Okay, N1 is actually for stirrer. Another one, T1. Let me find T1. Mana T1? This is flow. T1. Okay, this is T1. Kalau kamu perasan, sorry This is T1. T1 is for temperature. Okay. How do we switch on the stirrer and so on? Okay, so M1. Katakan saya nak buka stirrer. This is your control panel. So saya belum tunjuk lagi control panel. So in engineering, of course, every equipment akan ada control panel. So this is your control panel. Okay, what are the things that you can see? For this experiment, this is the main power lah to switch on. Okay, kamu tengok sini ada 2 button, right? M1 is for stirrer, T1 is for the water bath. So kalau saya buka stirrer, I have to switch on M1. If I want to switch on water bath, it will be T1. Okay, so let's say I switch on T1, you can see. So what happens when you switch on this one? Our water bath will function, and then of course they will start heat up the water. Then they will flow into the vessel, the heating jacket outside of the vessel. Okay, so nanti kalau eksperimen 1B kamu ada 2 temperature kan, means satu eksperimen katakan pada suhu, I cannot remember what temperature I gave you, katakan at 40. So at 40 we run the first experiment. Okay, so kita monitor conductivity, kita record conductivity sampai bawah 4. Okay, we flow out. We replace with new reactant. We repeat again the experiment, let's say pada suhu 70 Celsius. So kita panaskan ke 70 Celsius. Kita masukkan balik reactant yang baru. We switch on stirrer. We will run the experiment. Okay. So that's for experiment 1. Okay. So experiment 1, eksperimen yang paling senang tapi explanation dia a little bit long on the explanation. Okay. So that's for experiment 1, batch reactor. Eksperimen 1A saya tak buat live demo tau sebab eksperimen 1A ni bukan equipment. Dia adalah lab scale, dia guna beaker, dia kacau-kacau, dia titrate. So I did not show you the live demo for eksperimen 1A. Tapi it's very straightforward. So kamu tengok baca tu rasa kamu dah boleh faham. Okay, so this is eksperimen 1B. Right. So we go to the next experiment. Experiment 2. Okay, so experiment 2 is actually called continuous stir tank reactor. So this is the name of the equipment. Okay. So saya explain daripada control panel dulu Okay. So this is the control panel, sama je, tetapi of course different things lah you will be able to see. Okay, what is it? Right. So first of all, main power. Okay. So you can see next is all the buttons. Okay, the things that you need to switch on or switch off. Okay, so you can see every button or every operational will be labeled clearly and differently. Dia takkan ada dua butang atau dua control panel dengan label yang sama. Tak boleh. Sebab all engineers by right, okay, or all technologies, you should be able to understand this drawing. Okay, kamu tengok drawing ni kan? So later I will teach you how to see drawing dengan how to see the real equipment. So if ever you join the real industry or even you go to the laboratory, okay, as an engineer technologist, kamu sepatutnya kena pandai dan boleh baca this process flow diagram. So daripada process flow diagram ni, by right you can trace equipment mana, part mana equipment yang merujuk kepada diagram ini. Okay, contohnya, alright, I show you just one. Okay. So you can see here they write FL301. So FL is for flow. Okay. 301, you can read over here. You can see here label clearly FL301. So dia dah clearly state FL301. So next one, katakan kamu ada FL302, right? Okay, so 302. Kamu boleh baca, sini pun akan tulis FL302. Okay. Kenapa ada FL is to indicate flow. Kenapa ada 0102 to indicate first flow and second flow. Okay, so kamu takkan ada 301, sekali lagi 301. Tak boleh. Because 301 is very specific to this valve and 302 is also specific to this valve. Okay, to this flow, sorry, this is flow indicator, sorry, so this is very specific. So FI is for flow indicator, right? Okay, so this is how you translate reading of the PFD into the real equipment. Okay, the rest, so you see here P1, P2, so P is for pump definitely, so we have P1, we have two pump. Kenapa kita ada dua pump? Sebab we need to pump in two reactant. So two reactant, two separate vessel, two separate pump. Then we have apa ni? M1. M1 is for what? Stirrer. T1 is for heater lah, for the temperature. So T is for temperature. This kalau you need to use heater, you will switch on T1. If you need to switch on stirrer is M1. Okay. Now indicator. Okay, so you can see first Q1, T1, 401, 401. Q1 is for the conductivity indicator. T1 is temperature indicator. So kamu nampak di sini. You can see the top one is Q1, conductivity indicator. The bottom one is T1, temperature indicator. Okay, so by right, yang ni kena ada bacaan lah. Patutnya kalau we prepare sodium hydroxide at 0.05 molar, bacaan ni akan bermula daripada 10. Okay, tapi hari ni saya tak guna sodium hydroxide, saya guna air saja sebab tu kosong. Okay. However, please remember kalau eksperimen kamu, dia mesti bermula daripada 10. If you prepare the concentration accurately. Kalau prepare tak accurate, mungkin dia akan jadi 9, jadi 8, tetapi the base is about 10. Okay, so inilah bacaan yang kamu record dalam kamu punya data result ni yang kita record the conductivity. So sama je konsep macam batch tadi, kita record conductivity sodium hydroxide, then kita guna calibration curve, we get the sodium hydroxide concentration. Kita monitor based on conductivity dan concentration of sodium hydroxide. So this is a temperature 30.5. So imagine this is room temperature. It's very hot in this unit operation. Okay. So next one. Can you see F1301, F1302? Kan tadi saya dah tunjuk kat dalam apparatus, right? So this is the flow indicator tau. Dia ada sensor. This sensor is to probe sensor lah. Sensor to measure the flow rate. So volumetric flow rate sepatutnya. So F1, F1301, F1302. So kenapa ada dua flow indicator? One is for sodium hydroxide, one is for ethyl acetate. So this is the flow, dia punya sensor. Bacaan dia di sini ada panel. So nanti sensor ni akan hantar the isyarat, will hantar the signal to the flow indicator. So you will read the reading over here. So this is 301. This is 302 flow rate. Okay, so volumetric flow rate. So dalam eksperimen ni, kalau eksperimen 2A, kita akan kaji different flow rate. So different flow rate, different residence time. Ingat tak? Sebab residence time macam space time is volume over volumetric flow rate, initial volumetric flow rate. So kita akan guna flow rate yang berlainan. Flow rate berlainan, residence time pun berlainan. Kita compare performance dia. Okay, so kita akan bacalah bacaan flow rate di sini. So maybe you will ask, tapi doktor macam mana kita control flow rate? Okay, kita control flow rate guna this one. So you see ada V5, V10. V5 is connected to 301, sorry. V10 connected to 302. Okay, so kita akan control flow rate di sini. Okay, so we will switch on or switch off. Okay. Okay. So bila saya control sini, I'm supposed to read at 301. So saya control V10. So katakan saya nak naikkan ke, saya nak kurangkan ke, saya baca at 302. So you mean real experiment kamu nampak macam okay, kita control kat sini. Kalau kamu boleh nampak yang hitam tu, kita control kat sini, kita baca kat sini. Okay, so normally kalau real lab memang saya akan suruh 2 student control wave ni, 2 lagi student baca. Sebab kalau seorang nak buat dua-dua ni memang a bit difficult. Okay, so again, why 2 flow indicator? Sebab ada 2 reactant. 2 reactant flow rate kita boleh adjust and that's why we have 2 separate indicator. Okay, so tetapi this flow rate comes from where? It comes from the tank. So nampak tak ada 2 tank. So this one is first tank is for sodium hydroxide. B1 sodium hydroxide, B2 ethyl acetate. So this is B2. Tengok ditulis B2. Okay. So kalau kamu nak tengok dalam sini, kamu akan tengok dalam drawing dia tulis B2. Satu lagi kat belakang, sekejap saya bawa. Yang ni B1. So nampak tak 2 tank? So 2 tank ni kenapa? Sebab dia ada 2 reactant kan. So reactant ni is store separately before dia pump masuk reactor. So 2 tank ni is just feed tank, belum lagi reactor, it's just feed tank. Kenapa tadi batch tak ada feed tank? Sebab batch kita just masuk dalam reactor, kita tutup, kita biar reaction takes place. Tapi kalau CSTR kita kena continuously pump in the reactant to the reactor. So kita kena ada feed tank yang standby, kita akan pump masuk continuously ke dalam reactor kamu. So you can see down here, you got 2 separate pump. Kenapa 2 separate pump? 1 pump for each feed tank. So dia akan pump, okay, masuk. Kalau kamu tengok kat bawah, the pump, okay, you can see this is the valve, okay, kedua valve ini. So kalau kamu perasan valve ini, kejap I show you Okay, so you see here, alright, when you switch on the pump, what happen? They will pump in from here, goes to here. This one akan pergi kepada flow indicator, flow rate. Dia akan flow masuk ke dalam reactor yang tu. So again I show you. I hope you can see. Pump in from here, goes into here, goes into flow indicator. Okay, nampak flow indicator, masuk ke dalam, yang putih tu ke dalam reactor. Sama untuk tank ni daripada bawah, okay, when you open the pump, they will pump in, okay, it goes from here to the second flow indicator and then again goes to the reactor. So dia punya konsep, kalau continuous, mesti ada 2, depends how many reactant you have 2 reactant, 2 feed tank, 2 pump, okay, goes to flow indicator, flow sensor, goes to the valve, you control the flow rate, flows into the reactor. So that's how you control the volumetric flow rate during the operation. Okay, now I show you the reactor. Reactor dia adalah ini. Okay, so kejap saya switch on stirrer. So this one probably you can see the stirrer better. So ingat kat CSTR, dia macam batch, dia ada stirrer. Okay, although beza dia, batch is a closed system, CSTR open system. So open system tu maksudnya kamu tengok, okay, dia akan sentiasa mengalir. Okay, you can see flow kat atas. Dia akan mengalir masuk dalam reaktor. I hope you can see. Dia akan mengalir masuk sini. Ni you can see one here. Ni adalah untuk sodium hydroxide. Another side. Another side one more. Here one more is for ethyl acetate. So dia akan ada dua inline to the reactor sebab dia kena flow in dua reactor kan. So dia kena ada dua inline yang masuk ke dalam reactor. Okay, so kita sini tulis R1 reactor. Okay, so ada stirrer. This is also a 10 liter reactor. If you can see the volume is stated clearly. So dia akan sentiasa pump in. Okay, kalau kamu perasan, kenapa saya kata this is open system? You can see. Kalau batch dia sampai sini kan, kita keluar kat sini kan kalau batch. Kalau CSTR you see, it's connected to here. Connected, pump in balik masuk dalam kamu punya, dia pump in ke dalam product tank. So it will continuously flow to the reactor, continuously flow out to your product tank. Kalau kamu nampak. So, out. Connected here, by right atas lagi. Atas. Okay, dia akan sebenarnya mengalih keluar di sini. So this is your product tank. So imagine dalam industri, dia akan collect produk daripada product tank. So tadi kalau batch, dia collect daripada bawah ni kan. So tak boleh sebab continuous dia akan flow in, flow out, flow in, flow out. So tapi volume kat dalam tu kena maintain. That's why dia ada feed tank, ada product tank. They will flow out to the product tank. Okay, so kalau eksperimen 1A, dia just tukar flow rate. Eksperimen 1B, dia tukar temperature. So kalau tukar temperature, we need the same concept. Kamu kalau perasan, there's two vessel here. One outer vessel is your heating vessel or heating jacket. The inside one is your reactor. So dia pun ada water bath. Water bath dia adalah di atas. You can see this is our water bath. So water bath will heat up the water. So then the water will become the heating fluid. They will flow in. Saya tak buka dia punya heating jacket punya sistem. But you imagine yang air tu akan berada di bahagian luar. Air tu akan panaskan reaktor kamu. So you will run at different temperature lah. Kita set water bath kita pada 40 and then habis eksperimen we change to 70. Okay. Then another thing, remember I told you kita still measure conductivity kan. So where's the probe? This is the probe. So kamu nampak probe ni ada dua. TI, temperature indicator, QI, flow conductivity indicator. Ingat tak? Kan kat panel sistem kita kan dia boleh baca dua-dua kan? So probe dia, yang ni lah probe dia. So you can see the black rod. Kalau kamu nampak, anda pada clear kot, black rod ni akan berada di bawah. See here? So this probe will will measure your conductivity, measure your temperature. Dia akan hantar signal kepada bacaan at control panel. So this is how you do it to measure the conductivity. So sama je konsep dia. Ambil bacaan conductivity, guna calibration curve, kita akan dapat concentration of your sodium hydroxide, your reactant, and then we were able to calculate the conversion of the sodium hydroxide. Okay. So kalau nak tengok pump, this is clear view of the pump of course lah. Dalam CSTR ni, it's only 10 liter, so pump dia kecil je lah. Tapi kalau kamu pergi industri, 20 liter, 50 liter, the pump is going to be very huge pump. And then sama konsep stirrer ni, kalau reaktor dia panjang dan besar, you might have multiple or even 3 stirrers at one time. Okay, so you can see by yourself, right? This is a single CSTR. Satu je CSTR that is functioning at one time. Okay, so apa ciri-ciri utama dia? The main characteristics, 2 feed tank, 1 reactor, 1 product tank. Okay, so you can see memang kompleks kan sistem dia. Kalau batch nampak macam tak kompleks kan, tapi continuous CSTR is a continuous system. You can see it's a very complex punya configuration. Okay, kamu nak, because you need to pump in and then you need to pump out, you need to collect, so on and so forth. Okay, so we are done on CSTR. However, as again I told you, if you don't understand, if you have problem doing the lab report, okay, please contact me. I will be able to assess you. Okay, so memang lebih baik sebenarnya is physical lah. Tapi of course, as the situation is like this, it's also quite fine. Don't worry. Okay, so again, this is the PFD diagram lah. So for those yang ambil design project 1 next semester, budak proses, I will actually teach you how to actually do a process flow diagram of your own chemical plant. So bayangkan nanti dalam proses design project 1, you will come up with your own drawing. Okay, tak sesenang, yang ni senanglah sebab hanya satu equipment. Tetapi design project tu sometimes you have until 10, 20 equipment, you have to draw the entire process flow diagram. Okay, but don't worry, I will teach you how to do so. Okay, so before we go to the next reactor, let me switch off first. So saya switch off stirrer, saya switch off pump 1, saya switch off pump 2. So nak tengok apa indikator apa berlaku bila tutup pump? Tak adalah flow. Senang je. Tak ada pump, tak adalah flow. Okay. Then, what is the problem with continuous system? Okay, saya lupa nak bincang pasal ni. CSTR, apa problem dia? Okay, kalau kamu nampak, you can see there's a lot of leakage, spillage on the floor. So, kamu kena ingat kenapa? Because I think in this case, the pump is leaking. Okay. And sometimes some of the piping is leaking as well. Itulah masalah continuous. Dia kalau especially pump lah or any leakage anywhere. Okay, kamu tahu kan kalau leakage means your reactant is not flow in accurately. Sebarang perubahan ataupun sebarang kehilangan will result in different outcome. So tu masalah continuous. Okay, sebab dia sedikit any problem especially pump, kalau macam contohnya if your pump, katakan kita set je, saya switch on balik. Okay. Okay, kalau kamu perasan, let's say saya adjust flow rate. Okay, so harap kamu boleh baca. Kamu kalau boleh nampak kan, flow rate dia fluctuate, right? Saya dah tak kacau flow meter tau, saya dah tak kacau watt, tapi flow rate dia fluctuate. Faham tak indikator masalah dia? Masalah dia bila saya set katakan 80 ml per minute, okay, 80 ml per minute, tapi dia tak constant 80 ml per minute. Kamu tengok dia fluctuate. Kejap 80, 81, 82 kamu boleh nampak. So this is also a problem tau. Flow rate dia tak constant. So bayangkan kalau kejap 80, 81, 82, 83, dia mesti akan influence reaction as well. So that's the main problem with continuous system. When certain parameter fluctuates because of the system, reaction will be influenced. So that is actually the main challenges of a continuous system. So imagine if you are working in a chemical plant and you are a plant technologist or plant engineer, or you are someone who taking care about all this system, you memang stress lah because you tengok sedikit perubahan memang you will stress because you know outcome dia akan tak sama sudah. Okay, so itu adalah in contrast to batch. Batch tak ada masalah ni, tetapi batch dia setiap kali you have to change new batch of reactant, ada masalah dia jugalah. Alright. So we go to the third experiment. Okay. So this is kalau tadi kamu rasa CSTR kompleks kan? This is plug flow reactor. It's even more complex. Okay. Tapi sama je konsep dia. Okay. So katakan one day you are interning. Okay. Your boss shows you reactor. So first thing kamu nak identify dia open system ke continuous system. This is the way. Kalau dia mesti ada feed tank, tak semestinya dua. Depends lah, kalau satu reactant, satu feed tank. If you have two reactant, maybe two feed tank. So kita ada dua feed tank. Nampak sini B1, B2 feed tank. Kita ada reactor, so this is your reactor. So reactor ni apa? Plug flow reactor. So kalau kamu ingat saya ajar kamu kan, yang reactor tu ialah yang kat dalam tu. You see the core tubes. The core tubes is your plug flow reactor. Tengok dah lama tak guna pandemik kan. Reaktor ni pun dah ada ulat already. So this is because dah lama tak bersih. But it's very easy ni. Guna je solvent, kita tak boleh bersihkan. But pandemik kesian. Reaktor pun pandemik pun terbiar. Okay, so the core inside is the plug flow reactor. Kamu dapat kat luar ada vessel lagi kan. Vessel kat luar ni adalah your heating jacket. So kat luar ni nampak ada air kan sebab we put in water. Sama konsep lah, use water as your heating fluid. So you see how big is your PFR? Dia call sampai ke atas. So dia akan masuk pada mana? Okay, saya explain lagi Okay, then next, this is your product tank. So sama konsep. Flow in, flow out. Tetapi apa beza dia? Okay, macam ni. Okay, you got 2 feed tank, right? Okay, I have to pump into the reactor, right? So nampak ada pump kat bawah. So nampak ada 2 pump. 2 yellow pump, right? Pump 1, pump 2. P1, P2. Each pump for each of the vessel. Okay, then next, right? Switch on kat sini lah. So kamu nampak bila saya switch on P1, P2. So both pump will be functioning. Dia will pump. So dia pump macam mana? Dia akan pump daripada B1, B2. Let me see if I can show you clearly. Okay. Okay, this one. Okay, this is for B1. I explain for you B1 So, kejap. So, B1, you can see from here. Dia akan, saya pump kan? Saya akan pump. Kamu nampak tak dia masuk ke sini? Sorry kalau kamu tak dapat clear. Okay, dia akan masuk di sini, bawah. Sini, dia akan masuk. Wait, let me check. Let me trace I'm supposed to be able to trace this thing. Okay, sorry. Here goes to the pump. Okay, pump kan? Pump sini. Sini goes to V1. So V1 di sini goes atas. Okay, atas dah terputus. Goes back and then dia akan turun ke bawah. Dia akan turun ke bawah. Dia akan turun ke bawah sini. Dia akan masuk kat sini. Okay, basically, to cut story short, daripada feed tank, dia akan flow, dia kena make sure flow tu continuous tau. So, sistem dia akan jadi very complex because dia want to make sure the flow is always continuous. Ultimately, sebelum masuk reactor, dia akan flow ke sini. So, this is for sodium hydroxide. One more is for ethyl acetate. Okay, so kamu nampak kan? V7, V8. So, sama je. Dia ada 2 valve, 2 flow indicator sebab 2 reactant, 2 flow rate. So again, indicator dia kat sini. So ada 301, 302 sama macam CSTR kan? Okay, so then dia akan masuk PFR from the bottom. Dia masuk pada bawah. So kalau nampak dia masuk pada bawah tau. So 2 flow rate ni, okay, 2 flow rate ni goes in. Dia akan mix masuk. Can you see here? Dia ada Q1, T1, 401. So that is conductivity indicator, temperature indicator. So this is inlet punya indicator tau. Kenapa inlet? Sebab dia adalah dia monitor conductivity dengan temperature before it goes into the reactor. So kalau perhatikan dia akan flow masuk. Dia akan flow in. So kalau kamu bayangkan dia mengalir sepanjang coil tube ni sampai ke atas. So dia akan sebenarnya keluar di atas. So you imagine the difference with CSTR, dia masuk satu vessel saja kan. Satu vessel tindak balas berlaku dia akan keluar. Dia akan keluar pada the same direction. Tetapi yang ni dia ada satu inlet dan dia akan keluar at the opposite direction at the top. So kat atas tu kalau kamu nampak ada Q1402, T1402. So yang bawah adalah probe untuk inlet, yang atas adalah probe untuk outlet ataupun they will monitor conductivity and temperature after the reaction has taken place. Yang bawah ni is the probe for conductivity and temperature before the reaction has taken place. Sebab tu kalau kamu nampak kita punya bacaan akan ada 2. Nanti kamu nampak dalam table kan, table PFR lain dengan table CSTR tau. Sebab PFR akan baca satu probe sahaja, dia tak ada in dengan out. Sebab PFR dia CSTR dia akan the in and out is the same. The probe is inside the vessel. For PFR dia punya probe is at the outlet and inlet. Outlet, inlet at the bottom. Sebab tu you will have indicator 401, T401, this is inlet indicator, this is outlet indicator. Sama, dia monitor conductivity of sodium hydroxide. So, theoretically, kalau kamu perasan, conductivity inlet takkan berubah banyak sebab tindak balas belum berlaku. So, contohnya, if you prepare your reactant accurately, concentration dia 0.05, bacaan dia sepatutnya 10. Okay, so 10 ni takkan berubah tau. Dia fluctuate sikit lah, maybe 10, 9, something like that. But it won't fluctuate much. Or it will not decrease or increase. However, the outlet one will decrease. Sebab outlet adalah indicator conductivity, which is the concentration of sodium hydroxide with time. So kalau dengan masa, sodium hydroxide consume. Kalau consume, conductivity will decrease. So outlet conductivity kamu akan tengok mula-mula dia mungkin 10 sebab tindak balas baru nak berlaku. After that dia akan reduce. Tetapi inlet takkan reduce, most likely dia akan remain stable or just a little fluctuation. Outlet akan turun. Okay, next. Sama macam eksperimen 2, we got 3A, 3B. 3A is effect of flow rate, 3B effect of temperature. So kalau effect of flow rate, okay, kita kena control WAF, right? So the WAF is controlled here. Saya check. 302, 303. Okay, sorry. So 302 I think sodium hydroxide. 303 is for ethyl acetate. So this is the flow indicator. Flow sensor dia kat sini. Bacaan dia masih sama kat panel. So sensor akan send signal, hantar bacaan flow rate di sini. The second sensor will send the flow rate here. So where do I manipulate the flow rate? Kat sini. V8, V9. I will adjust my WAF over here. So nak increase ke nak reduce, sama konsep macam tadi. Okay, same concept. I adjust the flow rate here. I have to do the reading over here at the panel. So biasanya seorang student control WAF, seorang student akan baca. Kalau the same person doing it is very far. Okay, ni panel, control dia di sini. So one will control the flow rate, one will read the flow rate to adjust the flow rate. So sama konsep, experiment 3A tu effect of residence time. So when I change the flow rate, I will get different residence time. So, contohnya dalam sample of result tu katakan eksperimen 1, saya guna eksperimen pertama saya guna flow rate 200 ml per minute. So I calculate the residence time, I get the first parameter. Then second, I change the flow rate, okay, I calculate the residence time, I get the second parameter. So basically, effect tu kamu kaji bila kamu tukar dua parameter lah. Kamu tukar flow rate, 2 kali dapatlah 2 parameter yang berlainan. Okay, kalau temperature, samalah, I will change the temperature, I switch on T1. So I switch on T1, dia punya water bath tu kat atas. Tengok kat atas water bath dia. So if you are here doing the experiment, someone will have to climb the stairs, naik ke atas, adjust temperature water bath. Yang ni hanya untuk switch on. Nak adjust temperature kenalah naik ke atas. So kalau sama konsep kamu boleh nampak. You can see dia flow out kan, dia flow out. Dia akan flow in masuk dalam product tank. If you can see the flow, kamu nampak tak? Nampak kot ni? Kamu nampak dia akan flow out to the product tank. So this is the product tank. So same concept, flow from the bottom, goes to the top, reaction takes place, flow out, goes to the product tank. So this is the concept for plug flow reactor. Dia punya overall concept macam CSTR. The only different, vessel dia je lah. Ni vessel untuk PFR, yang tadi vessel untuk CSTR. Okay, so this is experiment 3. Okay, so I hope my explanation is enough. But again, kalau kamu betul-betul rasa tak faham, memang tak tahu macam mana nak buat lab report, please talk to me. I help you on this. Saya takut nanti kamu tak faham macam mana nak buat lab report. My worry, because usually memang students nak score is lab report lah. Means laboratory part tu memang senang nak score. Tapi saya takut kamu tak buat lab, you're not able to do so. Tapi previous semester memang senior kamu pun saya buat lab. Last semester dia boleh buat lab. The previous semester pun memang saya buat lab demo. So far okay. Tapi do talk to me if you cannot, you have difficulty doing the lab report. Okay, so done. Saya tutup pump. Okay, done. Next. So last one for today. Okay, then you're done for the lab. Experiment 4. Experiment 4 lah eksperimen yang paling memeningkan. Tetapi for me personally is the most canggih punya apparatus lah. Experiment 4. Tapi eksperimen 4 lah yang akan ambil masa, kadang-kadang 3-4 jam pun tak habis. You can see how complex it is, right? Okay, so Why is this complex? Okay, so because kalau eksperimen lain, you only study one reactor. This experiment 4, you will study 3 different types of reactor and configuration. Kamu tengok design sistem dia hebat tak? Okay, tapi biasa industri tak adalah sampai dia combine 3 jenis reaktor yang berlainan. Just that in this teaching lab, dalam apparatus ni dia tunjuk, dia compare terus 3 types of reactor. So what is it? Okay. First, this is your single CSTR, tapi ni lebih kecil kan, ni adalah 5 liter. Yang kat belakang tadi tu 10 liter, ni hanya 5 liter. Single CSTR. Then kamu nampak tak yang ni? Ni saya switch on the 3 series one. Ni 3 series CSTR. So kalau kamu perasan sistem dia akan flow kepada reaktor pertama, dia akan flow out, goes to the second reactor, dia akan flow out to the third reactor, baru dia akan flow masuk product tank. Product tank di bawah. Feed tank di sini. So 2 feed tank, 1 product tank. Okay, this is the reactor. So kamu nampak setiap reactor tu ada stirrer kan? This is 5 liter reactor. 5, bukan. This is, saya lupa lah. This is 3 liter, sorry. This is 3 liter. If I'm not mistaken, sorry if I'm not mistaken, it's 3 liter. 3 liter ke berapa? 1, sorry. 1 liter ni, saya tulis dah. Depan mata saya tak nampak, 1 liter. So 1 liter, 1 liter, 1 liter. Okay, then next one, plug flow reactor. Kamu nampak tak kat belakang? Yang atas sampai atas tu. See, this is your plug flow reactor. So dalam satu test rig ni kita ada 3 different types of reactor that you can compare the performance. Tapi kenapa eksperimen ni lama? Sebab dia kena run one by one. Dia tak boleh run simultaneously. Okay, memang impossible lah nak run simultaneously kan, sebab dia akan menggunakan still the same pipeline to the reactor. So dia tak boleh pump kepada 3 reactor at the same time. Okay, but let me explain more details about this experiment. Okay, so what you do, same reaction, same flow rate, same temperature, but we run on 3 different types of reactor. So nanti dalam kamu punya discussion, you have to discuss lah, okay, which configuration is better, so on and so forth. Tapi your conclusion tu is not blindly, okay? You have to calculate the rate of reaction and then you compare the rate of reaction. Sebab tu macam I advise you, before you do the lab report, please look at the slide yang saya bagi kamu last Monday tu, yang slide on the lab briefing. Sebab saya dah ajar kamu macam mana nak buat pengiraan dan macam mana kamu nak compare and then discuss for your lab report. Okay? So, let me go to the control panel. Control panel ni lebih kompleks lah sebab ada 3 reaktor kan. Okay, so apa beza dia? So, dia ada again P1 temperature. Pump ada 2, still 2 pump, P1, P2. Why only 2 pump? Again, here it depends on your reactor. Each pump is to pump for the reactor. Dia bukan pump reaktor berlainan, pump berlainan. Tak. Pump dia hanya berlainan if you have 2 different feet. If you have only 1 feet, 1 pump sajalah. So where does the pump situated? So it's here. So product feed tank kan? Feed tank, pump. So kamu perasan dia akan pump lah. Okay. They will pump into the reactor. So next one. Stir M. So M1, M2, M3, M4. M1 is the stirrer for the single CSTR. So cuba saya switch on tapi tak baiklah sebab tak ada liquid, patutnya tak ada switch on. Saya kejap je. So if you can see the stirrer is working. Okay, so saya tunjuk sekejap By right you cannot do this because kalau air tu rosak lah stirrer tu. Okay. Right, so you got M2, M3, M4. Why is it switch on? It's the stirrer for the reactor in series. So kamu boleh nampak kan stirrer dia? See the stirrer. Okay, alright, so done. Then kita tengok indicator. Kamu tengok ada 4 indicator. So many indicator, right? Okay, why? We go one by one. Okay, first Q1 for 1, T1 for 1. Again, conductivity indicator, temperature indicator. So where is it situated? So by right, kalau katakanlah kamu nak tengok panel, kamu nak cari kat equipment, kamu tak sure, what do you do? Tengok drawing. Okay, so this is the easiest way for you to know, nak trace the indicator. For example kan, kita nak cari kat equipment mana Q1 for 1, T1 for 1. Okay, so I will look at indicator kat mana Q1 for 1. You can see kalau kamu tengok clearly, it's actually here. Mana ni? Sini. Okay. So kamu nampak dia kata di bawah, di atas F1301, F2302, F1302, F1303, atas dia T1401, T1101. So if you look here, you can see indikator dia adalah di sini. Of course lah, mungkin kamu kata, yalah doktor dah run berapa kali, mesti doktor tahu lah. Which is true also lah. I already run this experiment. Berapa lama saya run I started 2009. Then I worked for 1 year in UniKL. Then I did my PhD in Japan. I came back 2013. Oh, this is my 9th year. Tahun ke-9 dah saya buat ni. Okay, faham. So this is the 401, TQ141, T1101. Okay, so kamu nampak kat reading, kamu nampak kat indicator, kat system. This is the probe dia lah. So ini adalah probe untuk conductivity dengan temperature. You can see the black probe. Sekejap saya tunjuk. Okay, the black probe mana ni? Okay, sorry. Oh, patutlah ke bawah sangat. Okay, the black probe here, this is the probe for your temperature and conductivity. So probe ni akan baca bacaan dia and then kamu akan baca di sini. Okay. So kalau kamu perasan, this probe kan adalah sebelum dia masuk kepada reactor. That's why this probe is actually the inlet probe for the conductivity dengan suhu. Ingat tak macam PFR tadi? So macam PFR tadi dia ada inlet probe, dia ada outlet probe. So probe ni adalah before it enters to the reactor. So same concept lah. So conductivity dia sebab inlet reaction haven't occurs. So dia akan fluctuate a little bit tapi dia tak akan decrease atau increase because inlet probe reaction has not taken place. Therefore, sodium hydroxide is not yet consumed. Hence, dia punya reading will just fluctuate, will not decrease. And by right, dia kena dalam 10 lah. Tapi sebab saya guna air, sebab tu conductivity dia very low. By right, it's about 10 if you use sodium hydroxide. Okay. Kenapa ada lagi 3 probe? Okay, so probe pertama, kenapa ada 3 probe? Sebab dia akan measure conductivity and temperature for the 3 different reactor. Okay, saya tak ingat. Saya rasa 402 is for single CSTR. Tengoklah senior kamu dah conteng. Dia tahu saya tak ingat kan, dia tolong contengkan untuk saya. So this is for single CSTR. This is for PFR. Tengok betapa baiknya dia takut saya lupa dia tuliskan. Ini PFR punya probe. This is for 3-stage CSTR. See? Dia tuliskan juga. 3-stage CSTR. So 3 stage, PFR, single stage. So mana kat equipment dia? Okay, kalau kamu kata kamu tak sure kat mana dalam equipment dia. Okay, kejap saya tengok. So this is 403, kamu tengok 3 stage kan kamu nampak kat sini. Saya tengok terus dalam 3 stage. Mana dia punya indicator ni? Tengok dia tulis sini. T1 4103, Q1 403. So dia akan berada pada reaktor yang ketiga. Tengok 1, 2, 3, probe pada reaktor ketiga. So you find at your reactor. There you can see probe dia pada reaktor ketiga 403, Q1 401, T1 103. So this is the again conductivity and temperature probe for the outlet conductivity and outlet temperature of 3-stage CSTR. Kalau single stage kat atas, you can see clearly. Yang ni single stage. Kalau PFR, I cannot help you, it's too up high. You can see yang warna hitam tu atas sekali. So probe dia very high lah. Okay, so the probe will send the signal and reading to the control panel. Okay, so done. So next one, flow indicator. So sama je, tengok sudah sini kamu dah tuliskan baik betul. So FI302 flow indicator for NaOH. FL303 indicator, flow indicator for ethyl acetate. So ditulis sekali wah dia terus. V9 control 302. V10 control 303. In your real chemical plant you cannot do this kamu jangan tulis, jangan conteng Okay, dalam lab ni tak apalah, but in the real chemical plant don't conteng Okay, tapi senanglah kan dia buat macam ni. Okay, so I want to control this flow rate. I go to V10, right? V10 is here ni. So this is V10. This is V9. Okay, so don't follow my rule saya guna tangan je. But because saya guna water is okay. But if you use chemical, real chemical, you have to use what do they call it? Sarung tangan. Imagine, I cannot even remember. Sarung tangan. Okay, so please don't follow my example. I don't even wear, tapi Barat you have to wear. Okay, so again, sama concept. I control flow rate here. I adjust flow rate. I read over here. So nampak sekarang bacaan dia. Okay, nampak bacaan dia. Okay, again, masalah dia, bacaan dia fluctuate. So itulah masalah flow system. We have difficulty in maintaining the flow rate. So flow rate berubah, residence time mesti berubah. So katakan kamu adjust residence time dia 5 minit. Tapi the real one kejap 5 minit, kejap 4 minit, kejap 6 minit. So dia tak accurate sebenarnya. Okay. So we got two flow rates, two flow warp sebab two reactant. Okay. Then kalau kamu perasan, dia ada banyak warp lagi. 3 warp, 3 here, 6. So V12, 13, 14, 11, 19, 20, 21. Kenapa? Because each warp, okay, yang 12, 13, 11, 12, 13 ni for each of the reactor. Maksudnya contohnya sekarang saya guna 3 stage CSTR, I will have to open 12. So bila saya buka 12, apa yang berlaku? Dia akan flow masuk ke dalam 3 stage CSTR. So katakan kalau saya nak buat untuk single stage PFR, single stage CSTR, saya akan tutup 12, tutup 13, buka 11. Kalau PFR, tutup 12, 11, open 30. Only one valve can be open at one time to allow the flow to the specific reactor. You cannot open all three. Dia takkan dapat pump kepada semua tiga-tiga reactor. Then subsequently ada another 3 more valve, right? So this 3 valve is for the valve to allow the reactant to flow to the product tank. So contohnya kalau kamu tutup ni, tak boleh dia mengalir keluar kan sebab dia continuous, dia kena flow in, flow out. So we open 12, flow in. We will have to open 21 for 3 stage supaya dia boleh flow out. Kamu nampak kan dia flow out kan? Sebab daripada 3 stage ni kamu nampak, okay, dia akan flow out kepada sini. Okay, I can show you this clearly. Nampak kan? 3 stage kan, the last reactor. Okay, kamu nampak sini kan? Here, okay, I show you like this. Okay, here, you see here. Okay, you follow my hand. Masalahnya tangan saya. You follow my hand. Okay, here. You can see dia akan flow to 21, then flow to the product tank. So flow in from the top, first reactor, flow to the second, flow to the third, flow out to V21 valve, and then flow to the product tank. So untuk eksperimen ni, it takes time sebab each reactor ni katakan ambil masa sejam. So you run single stage. Habis, buka valve, tutup valve, goes to single CSTR. Buka valve, tutup valve, go to the third plug flow reactor. Okay, so you can see that this configuration is more complex purely because they combine 3 types of reactor at one system. However, in the real chemical plant, you will not see this. Okay, you will only see a single one lah. Single PFR ke, single CSTR ke, atau kalau ada pun if the reactor are in series. Contohnya, okay, katakan dalam kamu punya apparatus tu, sistem dia adalah these 3 reactor in series. Okay, so this is a more complex system lah purely because of that, right? So for this experiment 4, okay, dia satu eksperimen, tak ada A, tak ada B. You just compare the performance of the reactors for the same reaction, same temperature, same flow rate. So you are supposed to calculate sebenarnya kamu hanya kena compare the minus RA, rate of reaction. Jadi kamu kena kira tau rate of reaction. Jadi kamu compare je, mana reactor ada rate of reaction yang paling tinggi. So the reactor with the highest rate of reaction is by right the best reactor configuration lah for the system. Okay, so actually that's all for our experiment. Hold on, let me switch on video up. Okay, so we are done for the experiment. So it's very hot. Okay, right. So to conclude for our lab demo, I've already shown you the 4 experiment. Okay, so make sure you see the timetable to know either you're doing experiment A or experiment B. And saya pun dah bagi kamu timeline kan, setiap eksperimen tu you will submit the lab report every 2 weeks. So the first lab report due date dia minggu 8. So you have minggu depan minggu 7 kan, you got one week of semester break. Nah, minggu seterusnya minggu 8 you will submit the first lab report. Okay, just lab report. Yang pre-lab dengan psychomotor tu you don't have to worry. I will do an online quiz. Sekali je buat quiz dah settle untuk pre-lab dengan psychomotor. When is that? I will upload the question dia VLE, kamu jawab kat VLE. I will try to do it by this week. Tapi don't answer it too early lah sebab kamu sepatutnya kena faham dulu lab dia. Kamu buat lab report, kamu dah settle, baru you do the pre-lab online quiz dengan psychomotor assessment. My last word for lab report, please don't burden yourself, tak payah buat panjang-panjang. If you know my style, as long as you hit the point, apa yang kamu patut discuss, sebab dalam lab manual tu, I already explain to you what you're supposed to discuss. As long as you do, you calculate, you discuss apa yang sewajarnya, it's already okay. So tak payah buat lab report yang panjang-panjang. Saya tak nak, I really don't want to burden you because you got a lot of work. Okay, so this is one way how you're able to do it better. Okay, short and concise yang penting untuk reaction engineering. Right, so that's all for today live demo. Thank you for attending the lab, and I apologize sincerely if you're not able to really catch the part masa saya terangkan tadi. Okay, so if you really need additional help, please contact me. I will try my best to help you. Okay, so thank you. Have a good day. So before I forget, kita dah tak ada kelas minggu depan Isnin pun tak ada kelas. Rabu tu we will do the examination lah. So exam start at 9:30, the test 1. 9:15, I will email the question already to you. So 9:15 tu email to your student email. So make sure you check. Kalau tak dapat soalan, inform me. The exam is from 9:30 to 11. Okay, 90 minutes. So 11 until 11:30, you're given 30 minutes to compile, to combine, then to one PDF file, submit dalam VLE for your test. Okay, so any problem, just contact me personally. Okay, alright. So that's all for me. Thank you everyone. Have a good day.
Thank you, Doctor.
Bye.
Thank you, Doctor.
Bye.